have to try to cram it and do all the quiz through all this stuff tomorrow. We will not do that. What we'll do is we're going to add in an extra section. Basically, it's like a section and a half. And we'll quiz towards the end of next week. I know next week's a weird week, but it won't be that big of a deal because, in all honesty, the stuff that we're going to do over the course of, we're going to do more word problems today, and we'll finish them up tomorrow and start 5-3. Honestly, the 5-3 takes a whole whopping 4 minutes to show you guys how things work. It's the 5-4 section that takes an extra bit of time, but honestly, it's very, very simple. So I don't think it's going to be that big of a deal. I've looked back on some of my previous year's notes and stuff that I've done, and usually the first quiz was over up through 5-4 anyway. This year I was just trying to do it before the 3-day weekend, so not the end of the world. We'll still be on the same pacing. So anyway, yesterday you guys left off. I think we left off at on the back end where we were tossing things in the air. I think we started that one. Then we get to the projectile launched vertically, the 96-foot tall thing. I don't think we got there. So this is on that. Okay, so we're at the third one then? Okay, so the third one, let's look at it. I couldn't remember. Yeah, and if you're able to figure them out, great. If you didn't quite figure it out, it's not the end of the world. Today I was going to kind of go through a couple more of them and try to start reminding us how do you search for zeros? How in the world do you adjust your scale, your windows, things like that? One of the things that I did notice yesterday while she was up here showing you guys how to do some stuff, some of you guys were getting lost in your windows, and your windows were coming up with errors. One of the things that happens on your error window, if you get in what they say invalid dimension, and then it might say stat plot on there, that meant that somebody that had your calculator last year finished off their final doing a statistics problem, that they were utilizing the stat plot button and didn't turn it off. So to fix that, I want everybody to do this right now. What we're going to do is a reset. And for us to do a reset, we use it. And this is kind of like your Control-Alt-Delete option on your calculators. I want you guys to hit second plus sign 712. And then after you do that, do second plus sign 722. What that does is that it gets rid of all different weird things that might have been thrown in there, and it restarts the defaults. When we restore the default, the idea of where you get that accidental stat plot thrown on, it's off now. Okay? It shuts itself off. Also, on the very back of your calculator, there is a little reset button. It might be covered by tape, so don't peel the tape off. But if worst case scenario, you need to use, you can probably use your pencil. Oh yeah, some people have the tape, some people have that. Just that little. If you can poke through the tape if you had to with a paper clip, and it will just redo everything earlier. I had a student first hour whose calculator was stuck, just spinning. It was just stuck in an infinite loop. So we had to figure out what to do. So we hit that button and it went away. So those are your two worst case scenarios. Honestly, if you do this, I'd say 98% of the time it'll fix it. Okay. Very rarely do you have to do a hard reset. You don't have to do it. I'm just saying that I'm showing you just in case you ever had to.
What's the charge reset?
Wait, press a button. And all else fails. Go on. Okay. So, okay, you just want to charge it right now if you want. Here, you can't tell me. Yeah, remember, if your screen says your battery's low, I think it usually only takes 10-15 minutes on a charger, and it charges up pretty quick. So if he's nice, maybe he'll share it using calculators, but I wouldn't expect too much out of him. Keep your expectation low, then you'll be pleasantly surprised. So, it's so true. As you go into this one here, you are in standard form. Yesterday, I think I was talking with Wyatt about this. Do you guys know why all these problems are negative 16t squared?
acceleration of gravity?
No, it's gravity.
Oh.
It's because of gravity. So these are all physics problems. They're all what we call initial velocity. There's an initial velocity in each one of these style problems, but every one of those, what goes up must come down. So there's this constant of gravity, and they use it in math. We use it as negative 16 something squared feet per second. If you're in physics, I think they do 9.8 meters per second. Is it negative 9? Is it negative 9.8?
Yeah.
Okay. So that's what that is. That 48x, that 48t being positive, means that it was thrown at an initial velocity thrown upwards at 48 feet per second. That's what that 48 represents. It being positive means it went up. If it was negative, it means I threw it downward. So in this problem here, we have negative 16x squared plus 48t plus 160 gives the height of an object thrown from a building 160 feet high with an initial speed of 48 feet per second. T is measured in seconds. It's pretty standard for most of these types of problems. Find the time the object hits the ground and find the maximum height of the object. So, before you do anything with your calculator, what I always want you guys to do is kind of get a visual of what in the world this looks like. Is this up like a cup or down like a frown?
Down.
It's down like a frown. And we also know that that down like a frown thing is, since we're starting throwing it, where do you start throwing it from? What's the y-axis value? At 160. You know that you're starting at a y-intercept of 160. You know that since it's a parabola, it should be up and then down. Okay? You know that it has to be increasing still to the right of that point because you're throwing it upwards from that spot. You know that it has to go up still. So the maximum has to be to the right of it. Just by sheer knowledge of what it looks like to throw something into the air. I'm hoping that most of you have thrown something in the air at one point in time. No? What's I'm going to. I'm very upset right now. I'm sad. What are you laughing at? Still like
No, it's on this one.
Why do you look so guilty? Anyway. Anyway, so you throw up, it comes down. Now, the idea here is we have to start messing around with our scale to try and see visually where it's going to wind up on our graph. This is where things got a little messy yesterday. So first thing we're going to do is put this equation in your y equals. So it was y equals negative 16x squared plus 48x plus 160. Now, this is where you start to think about what are possible values of x and y. Well, I know that my y value starts at 160 and it's throwing upward. So I would probably start guessing for my y maximum, maybe 250, 300, somewhere in that range. So go to your window, and I'm going to change my y maximum. My x maximum, I have it at -5, just so I can see a little bit behind it, and I have it out at 20, because I don't think that the ball would be up in the air any longer than 20 seconds if you're throwing it from that height. I can't imagine it would be floating that long. So my y minimum, just so I can see a little below there, I'm just going to change this to, I don't know, 300. I'm just guessing. Yesterday, when she was talking about the whole scale thing, The reason why she chose to put the scale at 20 is so that there aren't as many tick marks as you're looking as you're going up. That's the only reason.
Like one, and then there was like just a solid line.
Yeah, and that's fine. It's no big deal. And then I'm going to hit graph and see what it looks like. See if I got close. Oh, cool.
That's what I got.
Okay.
It renders the line. It looks like it's actually going on there.
I know, it's not bad. Okay. So now, at this time, the two questions that it was asking us was, how long was it in the air, and what was the maximum height that it reached? Well, the time that it was in the air starts at 0, because it's seconds, and then it goes around and it hits the ground here. So what we do is, it crosses over, this curve is going to cross over the x-axis at some value. When you cross your x-axis, what's the value of y? 0. So what we're doing here, we're trying to find the 0 here for the x value. Now, what this calculator does is that if we hit second calculate, whenever I say the values, she said second trace, it's the same thing. You're hitting the trace button, but the second value is the superscript there for calculate. I'm going to look for a 0. So I hit option number 2. I can do either press number 2 or just scroll down and hit option 2. Either one does the same thing. And now it's going to ask me for a left boundary. Now my calculator right now is at an x value of 7.5 and a y value of negative 380. Well, that means it's like down here somewhere. So I have to move my cursor so I can see it. So I want my cursor to be to the left of where it crosses. So I want it to be a positive y value. Okay? So I press left a bunch of times.
Just hold left.
Okay? All right. So in my case here, you'll notice between my y value at 16 and change, and then I go to the right, then it jumps to negative 4. So somewhere between x being 4.8 and change and 5.04 and change, it crosses the value. So my left boundary, I want my y value to be positive, so I hit enter. My right boundary, I want it to be negative, so I hit enter. And then it says, guess, I don't know, who cares? Hit enter one more time. It crosses at 5. How many seconds did it take to hit the ground? 5 seconds. Hey, why don't you let David watch this? Eventually, yes. Yes, sir. What's that? Yes, sir. Yeah, because most of these things, I mean, honestly, by this being a clean 0, this means it was a factorable problem. But, I mean, which is fine, but not always are they going to do clean. Okay. So here, we know that you get a 0 then at 5, so that means your second, in 5 seconds, it hits the ground. The other thing they want us to figure out is what's the maximum height. So what we do is, again, second, calculate, guys. And now we're going to look for maximum. So it's option 4. So if I choose this one, now I'm going to move my cursor to the left of where the curve is. And you just kind of guesstimate where it changes direction, which is fine. It doesn't have to be absolutely perfect. All right, so now I'm moving my way down. I'll hit enter. And then I'm going to go back over and see how it starts moving downward again, and I hit enter.
Question. When I saw it went straight to 195,
Don't use trace. Trace doesn't always work. Is that what you're using?
when we were just finding it, because it led perfectly to the.
Oh, that's just dumb luck. That's just dumb luck. Not always. And the reason why, the reason why it works in this,
195.
yeah, the reason why it works on this one, it's at 1.5 and your maximum is at 196. So this is just a cleaner setup. If you go back and look at the problem itself, you have zeros at 5 and -2. What's the halfway point of 5 and -2? 1.5. So this is a problem that does work if you don't use the calculator. Yes, sir.
So for finding the total time, can you just put like a line of y equals 0?
And find the intersection?
Yeah.
Isn't that just by plugging 0 where it's 0?
But
Same thing, isn't it?
So what's the point of putting the extra?
No, he's not wrong. He's not wrong.
but you know.
It's just more work. It works.
I forgot how to do the other thing.
Oh, just say calculate 0.
Oh.
Yes, sir.
Could you put in another rest like y equals 0 and then put the
What did you ask? It just takes longer to do that. Yes, sir.
I got it.
That's fine. No, because what happens here is I'm calling it 1.5 because I'm rounding it there. Yours is 1.500003. Doesn't it still go to 1.5? What happens is that you guys will get some little rounding error. Did anybody get for their 0 value like 1e to the negative 11? I've seen that a couple of times with this. That just means it's 0.000000000001, which in other words is called 0. Okay. You'll get rounding errors with a lot of this stuff, dependent upon what your window is set at. So by you being that close, I know it's the right answer. You're going to round it to 2 decimal places anyway. You're still going to be at 1.5. Yeah, what's up?
That means that there are 10 zeros in the decimal point and the 1.
That's what I said. You're going to do too many zeros. I don't know, I might have lost count. I'm old and can't remember things. Okay? Not terrible? That's kind of how this style of problem works. Okay, you're kind of going through those. What do we got? What about the other two? Were the other two okay? Same thing, really. Alright, let's go to the other packet then. We'll go back through a few of those. No. I'm going to do a couple examples. We're going to work off this one today. On this packet, I'm on page 5. And I'm at the football field. The multi-page one? You should have got this one too. Did you get this one? You guys got this one, right?
Mm-hmm. Yes.
So it means you got to pass it back. There it is.
Oh,
That's all right. No worries. Oh, that's a tough crowd. Give you crap. Look towards me. So, in this one here, they're talking about the football field. Why the football field or a soccer field has a crown to it. The reason why they crown things like that is because the runoff. Roads have that too. It's very subtle on most roads that otherwise the water would be pooling up everywhere. Water still pools up everywhere because you get ruts in the road after a road's been there for a long time. But anyway, I digress. So when they're looking at this formula here, the formula that they're giving you for the curvature of the field is that negative 0.000234 times quantity x minus 80 squared plus 1.5. Now this is all done in terms of feet. What format is that equation given to you? Yes, sir. Vertex form. So since that formula is given to you in vertex form, that means we have the following. Y equals A x minus h quantity squared plus k. Where's your vertex? 80 and 1.5. So we know that the vertex is located at 80 and 1.5. Where's your axis of symmetry? 80. Now, if you're using a tape measure to measure a field, where do you, if you start at one end, what is that one end probably starting at? At 0. So if I started at 0, it's got to go up through here and end there, right? How high up does the field get? 1.5. Think about that. It was 80 feet. think that the school is only like 30 feet up. That's a rather tough. You think of the calf workout you're getting when you're going up and down those hills.
What's the squat? Whatever that thing's called. 80 over how wide?
Depends on where you're measuring.
Because then it has to come down. Is the end zone elevated or level?
Anyway, so here's the thing. In this problem here, it asks you two questions. How wide is the field and what's the height? What's the height of the field? How wide is it? No. 80 is the halfway to get to the other end. Did you need to use a calculator? The idea here is that that's why we learn our different formats of quadratics. Once we learn our different formats of quadratics, we can take these little bits of information, whether it's subtle like this, where they're just saying, here's this crappy looking equation, but yet, oh wait, that's vertex form. I know where my vertex is. I know where my axis of symmetry is. I know that halfway through the field it's got to get here, which means the other half is another 80 feet away. Yes, sir?
Oh, that's how you know.
Yes, sir. What's that? Lengthwise it is, but the width you can do it.
I mean, lengthwise it could be B2.
Sure, it's just be 300 feet. Okay. That's how that one works. Sometimes it's a lot easier than it looks. Okay, this is a prime example of that. Let's go to the next page on page 7. Oh, first of all, the traffic engineering problem. I forgot to get a picture that came with this, so just you don't have all the info, so don't worry about it.
So cross it out.
Yeah, there's another image that's missing. But I want to go to Jackie Jordan Kersey and her shot put, and that's why I needed my tape ball. That somebody stole my tape ball. I think so. I didn't.
Because I remember throwing in the garbage, but then I recalled.
Very sad.
Stole it. And then I had that smug face. And then it never got out. And then
I just used it. Oh, never mind. I'm looking at it. Shut up. So,
well, last time I remember I threw it in the garbage and then you took it out.
alright. Shot put, because this looks just like a shot put. So, Jackie Jordan Kersey was competing in the heptathlon.
What's that?
7 hep. Shot put's one of them. I believe it's shot put, javelin, discus, 100-yard dash, probably something with the what's that, hurdle? High jump, and probably long jump or pole vault. So,
Wait, is that Olympics or Olympics?
hence it's in the Olympics. If you read the next sentence.
I didn't know that.
Anyway, so her throw of the shot put. You guys ever throw a shot put? So it says it's modeled by the following. Why is the A value negative?
Because you start
Because it goes up, it goes down. What does the 5.5 represent? Is it her height
or the ball, where the
ball's height? So she spins and goes, "Yeah!" Oh, that would have been pretty cool. I don't know if that's how she sounds, but it just sounds pretty cool to act like an idiot. But, take a minute, figure out what's the horizontal distance and how high up did it get? What's the horizontal distance it traveled and how high up did it go? Try and figure that out using your calculator. Now remember, we've messed around a lot with our windows. We probably don't think that she threw the shot put 300 feet up in the air. So you might want to adjust that a little bit. For what? Because it might.
If I were to ride bike.
Wow.
Yeah, you gotta change it.
But I don't know.
Well, you know that it starts at 5.5 feet for the wide.
Okay.
Now think about a shot put. You think someone's going to throw it 200 feet in the air? You think it might get it 20 feet?
That's really hard. Yeah.
I just leave it at like -5, just so we can see where it passes through. And then you're just kind of guessing about how far out it is. Yes, sir. Okay.
Wow.
All right, so.
Wow. Still going. I know. Oh my, this is
My window? -5,
Okay, now.
-30.
Got it. Finally.
You're probably doing this with
Remember, guys, you're just kind of moving, you're just kind of messing around with the window, so it's kind of getting over it's going to look like. There we go. Yeah, we can make this more difficult. I would wait a little bit far so we can just so we can see where it drops. Okay. So. Bless you. I don't know. Bless you. Bless.
This is correct. Like, do you have any 20.7? That's in the hundreds.
Yes, I got it.
What? No. Wait, we have
Each one of those kicks is a hundred. That is
Oh, I'm not far enough out. I want to see a front window. Okay. So I put I put my X maximum at 60. I think my Y maximum was at 50. Just a rough idea of what things would look like. That way we see the curve itself. So we're asking to figure out how far out did it go horizontally. So we're going to calculate a 0 out there. So second, calculate 0. And I'm going to move my cursor to where as close as I can get before it jumps from positive Y value to negative Y value. And remember, the reason why I'm saying positive and negative Y is because that's when it crosses the x-axis. So there's positive and there's negative. Okay. So if I use this as my positive, the other one as my negative, guess it does not matter. I just hit enter one more time. I'm getting it at basically, I always round 2 decimal places if I need to. I'm getting it at roughly 46.41 feet for the shot put. Okay. Now the next, yes sir. That's fine. Yeah. What is it? Like 1e to the -11 or something like that? Okay. That means it's pretty darn close to 0. All right. And that'll happen because your window is probably set a little bit different, and that's absolutely fine. Okay. Now to do the maximum again, we just do another second calculate maximum. Move back to the left of where the top is at. That's close enough. Enter, go to the right of it. I got a maximum. The maximum occurs at 20.75 feet out. It is 15.87 feet up. So the maximum height that it reached was 15.87 feet when she threw it. So well, this is a good question. What was the distance change from where it started? What would you do? No. Yeah. Subtract the initial height to figure it out. I mean, I'm just thinking of different ways that I could ask a screwball question. Okay. Remember what these values are representing. They're representing vertical heights over a specific distance. Okay. All right. Where are we at on time? Time to do one more here then. Let's go to page 11. And I have one that's a little bit weird that I want to make sure you see that kind of had a typo. Never happened with me, ever. Never screw anything up. Never. I'm looking at the top one. So the top one on page 11 talks about department stores selling 20 portable stereos per week when they are $80 each. The manager believes that for each decrease in $5 in price, 6 more stereos will be sold. So I had mistakenly or somehow printed this with the other part of the question hidden. Basically, I was going to ask you guys, what would the selling price be to maximize your revenue? Okay. So when we have this style problem where you have sale figures and a cost, I want you guys to always, always, always think of this one to be intercept form. I always want to go to intercept form with this one because you have your units sold at a specific price. But if you stop when you're done, that drives me nuts. There's one sound I hate. Thank you. I hate it. So, how many units are you selling at $80? 20. So, when you think about it, you're selling 20 of them at $80. The revenue that you make at 20 at $80 would just be multiplying those two together. The revenue would be what, $1,600? Okay. So the total revenue at this right now is $1,600. They're trying to increase their revenue by finding a different set of values because he wants to maximize it. So what we're going to wind up doing here is getting to it being a maximum problem. So I have to have one sale figure, one of these is going to go up while the other one's going to go down. That's how you get an A value to be negative. So when you read it, it says for each decrease of $5 in price. So the decrease in pricing goes over here, but does it tell you how many times you're going to decrease the price? No, that's the X value. The X represents the number of times you decrease it by 5. Okay? That's the number of times you decrease it by 5. The 6 you're adding in will be when you multiply that out, would be the number of times it increases by 6. So when we did one like this yesterday, we noticed that we had pretty clean zeros. So remember, when you have intercept form, it's going to help you to get your zeros. We know we're going to have one positive and one negative, and somewhere in the middle will be our maximum value, which gives us the best bang for our buck, how many times something should be done. So what's 80 divided by 5? It's 16, is it? Yeah, it's 16. So I have a 0 over there at 16. Yeah, 80 divided by 5, because it's add the 5, bring it over again. Good morning. Bye. All right. Okay. And then the other one is just a crappy number. The other one gives you at negative, because it would be negative 20 divided by 6, so you get negative 10/3. I don't know about you, but I really don't want to try to find an axis of symmetry with a negative fraction amount and a whole number. But guess what we have at our fingertips? A calculator. Do you need to FOIL that out to put it in the calculator? No. You can put in your calculator intercept form right away, and I'm going to show you how this works. So go back to your calculator again, and let's do change our y equals to parentheses 20 plus 6x, and then 80 minus 5x. Those were the two, right? Oh, I put 8, sorry. Thank you for catching that. All right. Now, from there, one of these days I'll get it right. Third time's the charm.
That would be a straight line. Oh,
And that's the thing, because now think about what you have right now. Your window is set from the last problem you did. Now, we know that if I multiply 80 and the 60, or 20, our revenue to start with was at what? 1,600. So that means we want to change our Y value going up. Okay? Now, also, since my graph right now, I think I had my X maximum set at like 50, I'm going to cut that in half to bring it in. Okay? Just because that's what my graph looks like. So I'm going to change my window. My X max was at 60. I'm going to change it to 30. My Y maximum, I know it went to 1,600, but we're hoping that it's still going to increase from there. So maybe 2,500? Are you saying no? What do you have it at? 3,000? Okay, I'll go to 3,000 then. My scale is fine if I should be okay. So let's take a look at what that looks like. All right, cool. Everybody get something similar to that ish?
What was your scale?
My scale was -5,
No, your Y.
30, 3,000. Oh, scale 5. And it doesn't. This Y scale should the curve should still be there without it. Okay. Now, what I want you guys to look at here is we want to calculate the maximum. Okay. We want to calculate the maximum, right? So second, calculate option 4 is your max. And we're going to move it around.
Archer's really pushing.
Okay. Hit enter, go to the right, hit enter, and hit enter one more time. So my X value in this case is kind of crummy. It's not a whole number. Isn't that 6 1/3?
Yep.
Okay. Isn't this 2803 1/3, roughly? So your revenue portion here, remember, your revenue is what when you multiply the things together. Our maximum revenue is $2,803.33. That's where that comes in. Now this multiplier of 6.3, this X value being 6.33, that's how many times you should decrease it by $5. Okay? So if I decrease it 6.33 times, or 6 1/3 times, I'm not selling it for just $80. I might be selling it for something in change. So what we do here is to figure that out. You're just basically taking your $80, subtract 5, excuse me, and subtract it. And that'll tell you what your cost is. Yes, sir? We're not selling 0.3 of a unit. Remember, that's how many times you're decreasing this out. What's that? For the units part, well, if you do this as 6 1/3, isn't 6 1/3 is what? 19/3? What happens when you multiply that out? Cleans. The denominator goes. There's no third of a unit.
What's the answer? Like, what was the
So again here, the selling price, if you sold, I think was it $48.35?
Yeah.
You sell it for $48.35, you're going to sell that amount. So sometimes when you're dealing with money, it's okay that the decrease or the increase in what you're selling it for could have that multiplier that's fractional. Because your units that you're selling, you're not selling half a stereo. Okay, you're still selling the whole stereo because the factors of the stuff will work itself through. What is that? 2 times 19 is what? 38. So you're selling 58. You sell 58 of them at $48.35. That's where it comes up with that pricing. Okay. On this packet you guys got yesterday, you should be able to do most of them, except for I wouldn't worry about the first page, I wouldn't worry about number 91. That's a little tricky. 97 on page 2, we might have to talk about tomorrow. 100, 101 is okay. Page 5, the top of page 5 is easy. Top of page 6, it's a little weird, but we'll talk about that tomorrow. 89 you can't do. And then the last few of them, you should be able to get through most of these things without too much of a hassle. I want you to try and get through as many of these as you can. On page 10, the bottom of page 10 is really weird, but the top is easy. Okay?
If I'm too confused.
I want you to get as many of them done as you can. Yeah, just go to the next one. That would be the calculator. Don't ever do homework that late. Stupid.